April 26, 1945, Novara, northern Italy. The textile factory called Manifattura Rotondi sat silent for months. The looms had stopped because the workers had been drafted into the war. But in the back of the building, behind locked doors, something else had been happening. The workers of that factory had been quietly assembling armored cars for a German contract. 6 AB-43s and one other vehicle, smaller, lighter, stranger looking, a scout car. When the partisans of the 81st Garibaldi Brigade rolled into Novara that morning under a young commander named Corrado Moretti, the factory workers handed them the keys, not just to the half-finished AB-43s, to the small one too, the Lancia Lince, the Italian scout car. And that is where this story turns from a footnote into a question, because the Lancia Lince was not really an Italian design. Every panel, every bolt, every line of its hull was copied, reverse engineered, stolen, if you want to use the harder word, from a British vehicle the Italians had pulled out of the desert sand 5 years earlier. A tiny two-man scout car the German officers in 1940 had seen on the battlefields of France and dismissed at first glance. No turret, almost no gun, less than 3 tons of metal, a kind of armored toy compared to the panzers rolling beside it. They stopped dismissing it very quickly. By 1941, in the dust of Libya, Italian engineers were on their hands and knees inside captured examples, taking measurements with calipers, drawing what they saw. By 1943, the Italian army was paying Lancia and Ansaldo to build a replica with an Italian engine and an Italian machine gun, but otherwise the same vehicle. By 1944, after the Italian armistice, the Wehrmacht had taken over the production line and was operating these Italian copies of a British design under a German designation, Pez SP WWII, Lince 202I. Take a moment with that. The Germans, who supposedly had the finest engineers in Europe, were so desperate for a small, fast, quiet scout car that they were running a factory in occupied Italy to copy a British design they had once laughed at. How does a vehicle that weighs less than a delivery van end up being copied by both major Axis powers? How does a design that started as a tender from a bicycle company beat anything sent against it on the road? And why has almost nobody outside of military historians ever heard the name of the engineer who drew it? To understand all of that, we have to go back to a competition in the English countryside in the summer of 1938. 3 companies, 3 prototypes, 1 specification from the British War Office, and a problem that, on paper, every army in the world was failing to solve. Part 1. The tender. Nobody expected. A bicycle company to win the British War Office in 1938 was an institution under enormous pressure. The new mechanized divisions being formed needed something nobody had built before. A vehicle that could find the enemy without being killed. A scout car, in their language. Small, fast, quiet, 2-man crew. Light enough to flick down a country road. Tough enough to survive a stray rifle round. Smart enough to disappear before the enemy could call in artillery. 3 companies were invited to bid. Alvis partnered with the Hungarian engineer Nicholas Straussler, who had already supplied armored cars to the Royal Air Force. Morris, who had built armored cars during the First World War and had factories ready to go. And, almost as a courtesy, BSA Cycles, the Birmingham Small Arms Company, a firm whose main fame in 1938 was making rifles, motorcycles, and small front-wheel drive sports cars for young men with more nerve than money. When the trials were announced in August 1938, Alvis was the favorite. Their car was the prettiest, the fastest in a straight line, and Straussler had the international reputation. Their prototype was even given the bold name Dingo, after the Australian wild dog. Morris was the safe bet. They had the production capacity and existing army contracts. BSA was the joke. A bicycle and motorcycle company whose vehicle department had been losing money since the early 1930s. The idea that a firm best known for two-wheelers was going to outdesign the established armored car builders of Britain was absurd to most observers. But BSA had something the others did not. They had an engineer, anonymous in the public record, his name buried in company archives rather than on plaques, who had been thinking very carefully about a problem most of his rivals had ignored. The problem was direction. A scout car's job is to drive forward, see something, and get out alive. The doctrine in 1938 said, "If you spot the enemy, turn around and run." Sounds simple. It is not. Picture the road. A narrow Belgian lane, a French farm track, a rocky North African wadi, tall hedges on either side. To turn around, you need space. You need to slow down. You need to do a three-point turn while a German anti-tank gun is finding your range. The BSA engineer's answer was deceptively simple. What if you didn't have to turn around at all? What if the vehicle could go just as fast in reverse as it could going forward? To do that, you needed a gearbox that gave you the same number of speeds in both directions. You needed a clutch that could disengage instantly without stripping the gears at speed. You needed a driver who could see backwards as easily as forwards. And you needed a four-wheel drive system that didn't care which way the wheels were spinning. The BSA prototype was completed in September 1938. By December, it had run 10,000 miles on roads and across country with almost no mechanical issues. 10,000 miles. To put that in context, the Elvis prototype was being eased over rough ground at 50 mm and worried about its center of gravity. The Morse design was struggling to make the speed requirement at all. The BSA car was already proving it could survive being driven hard every day for months on end. Then the War Office moved the goalposts. Looking at the deepening crisis in Europe, they added a requirement none of the original specifications had included: an armored roof, better protection on all sides. The little scout cars were going to face artillery fragments and aircraft strafing, and the Army wanted them to come home. For the other competitors, this was bad news. Adding armor means adding weight. Adding weight means changing the suspension, the engine, the cooling. For Elvis and Morris, it meant rebuilding the prototype. For BSA, it meant the same thing, but the bones of their design held up. The engineers' underlying frame and drivetrain were strong enough to absorb the changes. They came back with a strengthened suspension, a more powerful engine, an armored roof. And in May 1939, the British War Office placed its first order, 172 vehicles. The contract went to the bicycle company. There was an awkwardness. The name Dingo had belonged to the Elvis design. The Elvis design had lost, but the name had stuck in the trial reports, in the conversations among officers, in the memos passed around the War Office. By the time production started, passed from BSA to its sister company Daimler, also part of the BSA group, the men around the project had given up trying to call it anything else. The Daimler Scout car, the Dingo, named after a competitor it had beaten. And here is the first piece of the puzzle the title is asking about. Because in 1939, no one outside Birmingham knew this little vehicle existed. The Germans, building the famous Esden KF-6 222 with its fast-firing 20mm cannon and its rotating turret, certainly didn't. The Italians were still putting their faith in their L3 tankettes and the Lancia 1ZM, an armored car designed in 1915. When German officers drove past the first Dingos in France in May 1940, they saw a small, low, quiet thing with no turret and a single light machine gun poking out of the front armor. It looked like a piece of equipment a colonial police force might use to break up a market riot. Not a serious vehicle for a serious war. That impression lasted about as long as it took to chase one, because what the Germans saw rolling down the road was the outside of a design philosophy that none of their own scout cars had committed to. They saw shape. They didn't see what was underneath. And the moment they tried to engage one, the moment they tried to bring it to a stop, get a shell on it, force it to maneuver, they found out very quickly that the BSA engineers' quiet idea about going backwards as fast as forwards was about to ruin a lot of well-laid German plans. But to understand why the Dingo could embarrass German armored cars more than twice its weight, we need to look inside the hull, at a piece of engineering that, in 1939, did not exist anywhere else in the world. And once you see it, the laughter stops making any sense at all. Part 2. The transmission that broke every assumption. If you opened the rear engine cover of a Daimler Dingo in 1940, you would see a 2.5-liter, 6-cylinder petrol engine producing 55 horsepower. By the standards of the day, that is not impressive. A contemporary German said Kfz 222 had nearly 90 horsepower. A French AMD Panhard had over 100. By raw power to weight, the Dingo was nothing special. But power to weight is the wrong measurement. The Dingo's secret was not how much power it had. It was how that power was delivered to the wheels. And the centerpiece of the system, the part that made the vehicle behave on the road like nothing else in the war, was a transmission setup that combined two ideas Daimler had been refining throughout the 1930s. The first was the fluid flywheel. Most cars in 1940 used a friction clutch, two metal plates that pressed together to transmit power, and that you separated with the clutch pedal. Friction clutches wear. They slip. They burn out under heavy use, especially when you're constantly changing direction. The fluid flywheel solved the problem by replacing the metal-on-metal contact with oil. Two impellers, one driven by the engine, one driving the gearbox, suspended in a sealed housing of fluid. The engine spun one impeller, the fluid moved with it, the fluid spun the other impeller, and that drove the gearbox. No grinding, no slipping, no part to wear out. You could shift gears at any speed, in any direction, under any load, and the transmission absorbed it. The second piece was the pre-selector gearbox. On a normal car, you pushed in the clutch, moved the gear lever to the next gear, released the clutch, and prayed your timing was right. On the Dingo, the driver had a small lever near the steering wheel. He moved that lever to the gear he wanted next, but the gear didn't engage. It was just selected, pre-selected. Then, when he wanted to actually shift, he tapped a pedal where the clutch would normally be. The new gear engaged instantly, without him needing to look down, without him needing to time anything. Why does this matter for a scout car? Because shifting under fire, in fog, in dust, on a goat track in Libya at 60 miles an hour with a German half-track behind you, is not when you want to be wrestling a stiff manual gearbox. The pre-selector meant the driver could think one gear ahead, set it up while still doing the current job, and switch over with a tap of his foot. It meant you could go from third to reverse without doing what every other car in the world had to do, which is stop. Layered onto this was the truly radical piece. The Daimler Dingo had 5 gears forward and 5 gears in reverse. Same gearbox, same ratios. The same vehicle that could do close to 60 miles per hour going forward could do nearly the same thing going backward. The driver's seat was angled, tilted slightly so the driver could look easily over his shoulder while reversing at speed. The fourth piece was four-wheel drive, made possible by an arrangement called the H-drive. Power went forward to a centrally placed transfer box, then split left and right, then ran forward and back along each side to drive each individual wheel. No live axles. Independent coil suspension on every wheel. The drive components sat low in the hull, giving the Dingo a center of gravity so low it could take corners. Other vehicles would have rolled on. And in the early Mark I version, all 4 wheels could steer. Front wheels turned one way, back wheels the opposite way. Turning circle, 23 feet. Less than half what a contemporary Stit KKF said 222 needed. Now imagine you are a German motorcycle scout in May 1940, and you spot a Dingo. You give chase. You expect the British vehicle to do what every armored vehicle does when surprised: slow down, swing wide, present its flank, give you a shot. Instead, the Dingo stops, and then, without turning around, accelerates backwards down the road at almost the same speed it was going forward. You're now chasing an armored car that is reversing away from you at 50 miles an hour, behind a cloud of dust, while its co-driver, who has swiveled his seat through 180 degrees, can fire the Bren gun at you the entire time. Inexperienced drivers found the Mark I difficult to control. The four-wheel steering could cause rollovers if mishandled at speed, so later Marks dropped the rear-wheel steering. But the gear setup, the fluid flywheel, the pre-selector, the H-drive, the run-flat tires that didn't need a spare wheel, all of that survived in every mark of the design. The other thing that survived was the silence. With the engine in the rear, the H-drive components running smoothly through fluid couplings rather than chattering gears, and a low silhouette that swallowed sound, the Dingo at low speed was extraordinarily quiet. Crews who used them said you could roll up to within a few hundred yards of an enemy position and watch them through binoculars before they noticed you were there. For a vehicle whose entire job was seeing without being seen, that was almost cheating. The Daimler Dingo was not the most heavily armed vehicle on the battlefield. It was not the most heavily armored. Its single Bren gun would not stop a tank. Its 30 millimeters of frontal armor would not stop a German anti-tank shell. But that was never the point. The point was the equation hidden in the engineer's drawings. A vehicle that could see the enemy first, fire first if it had to, and get out before retaliation could land. By December 1939, BSA was building the first production examples. By the spring of 1940, they were arriving in France in the hands of the British Expeditionary Force, the 4th Royal Northumberland Fusiliers, the 1st Armored Division. Reconnaissance troops who had no idea when they were issued their new Dingoes that they were about to be the first soldiers in history to find out what this vehicle could do under fire. What happened to them in May and June of 1940 was a catastrophe for the British Army. The German blitzkrieg shattered the Allied lines. Tens of thousands of men were captured. The whole BEF was driven to the beaches of Dunkirk. By any measure, France 1940 was a defeat. But inside that defeat, in the war diaries of the reconnaissance regiments, in the captured equipment reports filed by German officers, in the small details that did not make the headlines, a different kind of story was being written. The men who couldn't fight a war alone, the men in the small armored cars with the strange transmission, and the engine that ran like it was whispering. They were getting home, many of them anyway, more than the math should have allowed. If a relative of yours served in the British or Commonwealth reconnaissance forces, in the Northumberland Fusiliers, in the 11th Hussars, in the New Zealand Divisional Cavalry, and they ever mentioned the little scout car they patrolled in, you may know more about this story than most museums do. Hit the like button. It keeps these stories visible. Part 3. France, the Desert, and the First Time. German officers stopped laughing. The Dingo's first combat was in March and April 1940, before the German invasion of the Low Countries. Photographs from those weeks survive, held by the Imperial War Museum, showing Daimler scout cars of the 4th Northumberland Fusiliers crossing open ground near Fontaine in March 1940. Two-man crews, helmets and leather jerkins, the slim, low-slung shape of the new vehicle, painted in dark camouflage, sitting astride a French country track that 6 weeks later would be a German axis of advance. When the German offensive came on May 10, 1940, the British armored car regiments were in a position they had spent years training for and never actually experienced. They were the eyes of an army that suddenly had no idea where the enemy actually was. Communications were collapsing. French divisions were dissolving. The panzers were not where the maps said they should be. And so the Dingo crews were sent forward again and again into the unknown. The Mark Thorm scout car was used during the campaign in France, where, in the assessment recorded by British military historians, it performed well. Its small size and limited firepower meant it was less likely to be misused than other reconnaissance vehicles. Its crews were not asked to fight rearguard actions against tanks. They were asked to find, report, and survive. That discipline, using a scout car as a scout car, not as a substitute light tank, is part of what made the Dingo's reputation. But there is something else recorded in the war diaries from that period. The crews wanted modifications. They wanted a more secure mount for the Bren gun, and they wanted the four-wheel steering removed, not because it didn't work, but because after long periods of cross-country driving, the steering linkages stiffened so badly that drivers couldn't manage the rear axle turn. That feedback fed directly into the Mark II, which appeared in the summer of 1940 with conventional front-wheel steering only. Many Dingoes never came home from France. They were burned, abandoned, captured, The Germans pulled them out of ditches and off of roadsides and sent them back to Germany for evaluation. They liked what they saw enough to keep the captured examples in service under the designation Leichter Panzerspähwagen in MKI 202E. Notice the E. The German military designation system used a letter to indicate country of origin. E meant English, English. Captured English equipment, deemed good enough by the Wehrmacht's own technical office to be put back into German hands and used. This is the first crack in the dismissive picture. German officers may have laughed when they first saw a dingo coming down the road. The German technical evaluators who took the captured ones apart did not laugh. They put them back into service. But the place where the dingo really earned its reputation was the desert. When the war moved to North Africa in 1940 and 1941, the dingo went with it. The 7th Armored Division, the 11th Hussars, the Royal Tank Regiment. The desert was, in some ways, the worst environment imaginable for a scout car. Heat that warped metal, sand that ground transmissions to powder, distances measured in hundreds of miles between fuel dumps, and an enemy, Italian forces first, then, from February 1941, Rommel's Africa Corps, who had armored cars of their own with bigger guns and heavier armor. The Italians, who were the first to encounter the dingo in the open desert, had nothing comparable. Their reconnaissance vehicles were either antiques, like the Lancia Lince, designed in 1915, or improvised camionette, Italian truck chassis with the cargo bay removed and a small gun bolted to a platform. None of them had four-wheel drive. None had run-flat tires. None could go 50 miles an hour in reverse. Italian forces did manage, during the back-and-forth fighting of late 1940 and early 1941, to capture some Daimler scout cars. Both dingoes and captured universal carriers impressed them so deeply that examples were shipped back to the Italian mainland for serious technical evaluation. That fact, dry as it sounds, is the moment the titles promise. Then the Italians copied it outright, actually started. In the present, in the desert, the dingo was doing what it had been designed to do. The 11th Hussars, mechanized since 1928, used dingoes for the screening and patrolling work that, in another era, would have been done by horse cavalry. They modified some with twin Vickers K machine guns, aircraft-style guns with very high rates of fire, lifted from the RAF and bolted onto the Bren mount. The patterns of use are documented in regimental histories. 2 dingoes and 2 Daimler armored cars per recce troop. The dingoes went forward first, slowly, listening, watching. If they spotted an enemy column, they would report by radio and slip back. If fired on, they used the gear arrangement that had made them famous. Stop, drop into reverse, and accelerate away the way they had come. But the dingo was not perfect. It had a clear, exploitable weakness, and the men who drove it knew exactly what it was. The flat plate underneath the hull, the same flat plate that let the dingo slide across uneven ground at speed, meant that the entire underside presented a smooth, exposed surface to a buried mine. A direct mine strike on a dingo was almost always fatal, though crews who survived to tell about it were the ones whose mine had detonated slightly off-center. The dingo was extraordinary at what it was designed for, and almost helpless at what it wasn't. It was a vehicle for finding the enemy, not for surviving the enemy's traps. In every theater it fought in, France, Belgium, Greece, North Africa, Italy, the Netherlands, Germany, its crews knew the moment of greatest fear was not contact with armor. It was the unmarked road shoulder. And yet, by the end of 1941, the Italian High Command had made up their mind. Whatever this vehicle was, whatever its weaknesses, they wanted one. They could not buy one. They could not be given one. So they were going to copy one, down to the smallest practical detail. That decision, made in Rome in 1941, is where the title's strangest promise begins to come true. Because the next chapter of this story is not about British engineers solving a British problem. It is about Italian engineers working under wartime conditions, taking a captured British design and reverse engineering it on a deadline. and then watching their own copy fall in 1943 into the hands of the Germans they had been allied with. Part 4. The Lynx that was a dingo in an Italian coat. In late 1940, with captured Daimler dingoes from the desert sitting in workshops at the Centro Studi ed Esperienze della Motorizzazione, Italy's military vehicle evaluation center in Rome, the Italian War Office issued a contract. The Fabbrica Automobili Lancia in Turin was instructed to design and produce a four-wheel drive scout car with independent suspension, a top speed of 80 kilometers per hour, and the same general configuration as the captured British vehicle. In plainer language, copy the dingo. Lancia did not pretend otherwise. The chassis they drew was, with adjustments for available Italian machine tools, the same chassis as the Daimler. The armored superstructure was, with some changes to the engine deck, the same shape. The gearbox concept, the preselector, the four-wheel steering, all carried over. The driver's seat was angled, the roof folded back the same way. Even the small detail that the Daimler crew used as a security trick, a bracket on the rear that the folded roof rested on so the driver could check the rear of the vehicle from his hatch, was reproduced. The differences were forced by Italian industrial reality. Lancia did not have a 2.5-liter inline-six like Daimler's, so they took the V8 engine from one of their passenger cars, the Lancia Astura, and adapted it. The Italian copy ended up slightly heavier and slightly slower on top speed. They did not have run-flat tires of the same quality, so the Italian Lince used conventional pneumatic tires, and the absence of run-flats turned out to be a crippling problem in service. Italian military documents repeatedly mention that the lack of suitable tires actually delayed the vehicle's entry into service. The Lince did not even come with a spare wheel. Italian designers did make one improvement. The Mark I Daimler Dingo had four-wheel steering that was difficult for inexperienced drivers and had been removed by Daimler in later marks. The Italian engineers kept four-wheel steering, but added a clever twist. On the Lince, the rear axle wheels did not steer until the front axle wheels were already turned all the way to the lock. In normal driving, the Lince behaved like a conventional car, but in tight turns, the rear wheels engaged automatically and dropped the turning circle to 3.9 meters, less than half what the Mark II Dingo could manage. The final paper drawings were ready on the 27th of January 1941. The prototype was assembled, modified through 1942, and presented to the Italian military evaluators in Rome on November 10th, 1942. After modifications for radio equipment, armament, and bulletproof tires, the vehicle was officially adopted by the Regio Esercito on March 29, 1943. That date matters. 2 months later, the North African Campaign, the very campaign in which the Italians had captured the Dingo and decided to copy it, was over, ending in the surrender of Axis forces in Tunisia. By the time Italy had a working copy of the British scout car they had needed in 1940, the war in the desert was finished and lost. But the production line had been built. The German Wehrmacht's interest in keeping it running was, if anything, sharper than the Italians had been. When Italy signed an armistice with the Allies on September 8, 1943, the situation flipped overnight. German forces moved to take control of northern Italy. The Italian Social Republic was set up under Mussolini, freed by German commandos from his prison high in the Apennines, and the German military apparatus took over the Italian armaments industry that hadn't yet fallen into Allied hands. The Lancia and Ansaldo factories that built the Lince fell into that category. On the 1st of October 1943, after analysis by the Oberkommando der Wehrmacht and the Heereswaffenamt Battalion, the German General Inspectorate of Panzer Forces formally confirmed the Royal Italian Army's previous order for 300 Lince scout cars. The Wehrmacht wanted them, bad enough to keep an Italian factory running through Allied bombing, partisan sabotage, materials shortages, and labor strikes, just to get a few hundred copies of an English scout car they could put under their own designation. The numbers in the records are messy because nothing about the production was clean. Ansaldo's records claim 100 Lince in 1944 and 28 more in 1945. Lancia's records claim 122 chassis assembled between May and October 1944, with a total of 250. A German High Command document from February 27, 1945, claims a total delivery of 104. The estimates range somewhere between 250 and 392 vehicles. But the point is not the precise count. The point is the principle. The Germans, in 1944, were running an Italian factory to copy a British design. In service, the Lince, under the German designation PES-SP WWII, Lince 202I, was used in the Balkans and in northern Italy. Wehrmacht reconnaissance platoons drew them. The 13th Panzer Division had Lince scout cars deployed near Bologna. A panzer training detachment in Lonigo used them through 1944 to teach scout car tactics to the next generation of German recce soldiers. They appeared in anti-partisan sweeps in northern Italy. The Italian Social Republic's anti-partisan group deployed at least one between the 6th and 9th of March 1945 against partisan units in the Asti area, 50 kilometers south of Turin. That particular Lince was ambushed by partisans near Santo Stefano Roero. The partisans captured it. There's a photograph that survives of those partisans wearing captured fascist equipment, standing on the Lince they had taken. And on April 26, 1945, in Novara, the workers of Manifattura Rotondi handed over their final Lince, the one we opened with, to the Garibaldi Brigade rolling through on the way to Milan. That is the unbroken chain this title is asking about. A British engineer at BSA in 1938 designed a small scout car that the German army initially dismissed. The Italians captured one in 1940 and were impressed enough to copy it. The Germans, having taken over Italy in 1943, kept the Italian copy in production for their own use. And the partisans who liberated northern Italy in April 1945 ended that chain by driving the German-controlled Italian copy of the British design through the streets of liberated cities in their own colors. Every step of that sequence happened because in 1938, an engineer at a bicycle company in Birmingham asked a question nobody else had bothered to ask. Why does a scout car only need to drive forwards as fast as it drives backwards? If your father, your grandfather, or anyone in your family served in a reconnaissance regiment, British, Commonwealth, Polish, Free French, or even the Italian partisans who used these vehicles in 1945, I would be honored to read their story in the comments. The names of the men who patrolled in these little vehicles are mostly not in the textbooks. The comments section is sometimes the closest thing to an honest archive there is. Part 5. The long shadow of a little vehicle and the engineer nobody names. By the end of the Second World War, the production numbers told their own quiet story. Daimler in Coventry had built 6,626 dingoes between 1939 and 1945. Ford of Canada, which had taken over a parallel production line at the Ontario plant in 1942, had built another 3,155 Lynx Scout cars to a dingo-derived design. Bigger, taller, less popular with the crews who used them, but rugged. The Italians, working under wartime conditions and German oversight, had built somewhere between 250 and 392 Lince Scout cars. The Australians had built another small batch, 245 of them, using Ford components and Marmon Harrington four-wheel drive kits, added up. Across the British Empire and across Italy and 3 different countries, more than 10,000 small scout cars were built to one fundamental concept, one engineer's drawings. And the production did not stop in 1945. The Daimler Dingo stayed in British Army service through the early 1950s. It was used in the Malayan emergency. The British Army of the Rhine kept dingoes in regular use until they were finally replaced. Not retired, replaced in 1952 by the Daimler Ferret, a vehicle whose entire design was a direct evolution of the Dingo. Same compact two-man layout, same rear engine, same H-drive concept, same emphasis on speed in either direction. The Ferret would itself stay in British service into the 1990s, which means that the small scout car concept the BSA engineer drew in 1938 was alive in the British Army inventory for nearly 60 years. The vehicle was not just a British and Commonwealth weapon. The Indian Army's 63 cavalry adopted Daimlers and used them in the 1962 Sino-Indian War. The Ceylon Army, later the Sri Lankan Army, received 12 Daimlers in 1959 and operated them into the late 1990s, including in the early years of the Sri Lankan Civil War. The vehicle was still in use by Cypriot forces and Portuguese colonial forces into the 1970s. The U.S. military, of all people, purchased 40 Dingo and Lynx variants for use in Vietnam. And here is the particular irony. The Daimler Dingo outlived almost every vehicle it had been designed to outrun. The German KF 222, that fast, hard-hitting little armored car with its 20mm cannon, went out of production in 1943 because there was no fuel for it and nothing for it to do. The Italian armored cars of the early war period, the AB-41, the Lancia 1ZM, were museum pieces by 1950. The Sherman, the Tiger, the Panther, the T-34, all of them were retired or scrapped within 20 years of the war's end. The Dingo just kept going. The engineer who drew it has, in most public accounts, no name. Some military history books credit the design generally to BSA's vehicle department. Some credit the engineering team at Daimler, where production was eventually polished and refined. Like a lot of British military engineering of the late 1930s, the design emerged from a team rather than a single-named genius. That anonymity is not unique to the Dingo. The cavity magnetron that made microwave radar possible, the bomb machines that broke Enigma, the mosquito bomber's wooden construction, all emerged from teams whose individual members are mostly forgotten. The Dingo's designer is part of that pattern, a man or men whose work outlasted 3 empires and whose vehicle was copied by 2 enemies. The lesson of the Dingo is not about heroic individual genius. It is about the kind of engineering that comes from listening carefully to a specific problem. The British War Office in 1938 didn't ask for a fast car. They didn't ask for a heavily armed car. They asked for a vehicle that could find the enemy and live to report what it had found. The engineer at BSA didn't try to add a turret or a bigger gun or compete with the Germans on firepower. He looked at the actual job and said, "This vehicle has to be able to leave the way it came as fast as it arrived." Everything else followed from that. The Germans, who had the better individual engineers in many fields, did not solve that problem because they were not trying to. Their scout car doctrine emphasized fighting power. Their armored cars were small tanks. The Italians, when they finally tried to build something like a Dingo, had to copy the British answer. They could not improvise their own. That is what the Lince's existence proves. The British answer was so far ahead that copying it was easier than redesigning around it. The verdict. 40 years after the war, in 1985, a Daimler Mark II scout car bearing the museum accession number E1985-96 entered the collection of the Tank Museum at Bovington in Dorset. It sits today on a wooden floor in a hall surrounded by larger, louder, more famous vehicles. Tigers, Shermans, Centurions. Visitors walk past it, often without stopping. Pause for a moment the next time you see one. Look at how low it sits. Look at how the engine cover slopes down toward the rear. Look at the swiveling co-driver's seat and try to imagine what it took in 1940 to be one of 2 men crammed into that compartment, knowing that when the moment came, your survival would depend on a transmission that had been drawn on a piece of paper in Birmingham less than 2 years before. Then think about what happened next. The Italians captured one and copied it. The Germans took over the Italian copy and kept producing it. The British kept building Dingos through every year of the war and refused to retire them until 1952. Their successor, the Daimler Ferret, served into the 1990s. The vehicle that started as a War Office tender to a bicycle company outlived most of the soldiers who first took it into combat. 6,626 built in Britain, 3,255 built in Canada, up to almost 400 built in occupied Italy by Italians for Germans, copied directly from a British design they had captured in the desert. an engineer whose name has slipped almost entirely out of public memory. The German officers who saw the first dingoes in France in May 1940 saw a small vehicle without a turret and without a serious gun. By their measurements, it was not a serious vehicle. By the only measurement that ended up mattering, the question of which design ideas the war would prove correct. It was the most successful Allied scout car ever built. The vehicle that was supposed to be the joke of the 1938 trials was, by 1944, being copied by men in Italian factories under German orders. That is the verdict. The doubts were real. They were also wrong. And the engineer who silently built the answer is one of the quiet, anonymous figures that stand behind a great deal of what we still call victory. If this kind of story matters to you, if you would rather hear about the unsung engineers and the small vehicles that did the unglamorous work than the big names that already crowd every textbook, hit the like button. It tells the algorithm that this kind of careful history is worth showing to other people. Subscribe if you want the next chapter, because there are a lot more of these designs and the men who drew them whose stories are still waiting to be told properly. The men who built the little vehicles and the men who patrolled in them mostly did not get statues. Many of them did not get medals. They got something simpler and harder to take away. They got the work that 80 years later still sits in a museum in Dorset, low to the ground, waiting to be looked at properly by anyone who passes by and is willing to slow down for a moment and remember. The vehicle weighed less than 3 tons. It changed the answer to a question every army in the world had been asking, and it carried in its strange, silent gearbox the quiet proof that sometimes the right idea, drawn carefully on a single piece of paper in a city where nobody was watching, can outlast empires.